All right, welcome back, everybody, to Chapter 3, Section 5, Inequalities involving quadratic functions. This is a section where a lot of people start making mistakes. They start doing something wrong. I'll caution you against the mistake that's made and work through the correct way to do these problems. So really, there's one objective here. Given a quadratic function in an inequality, can you solve it? So I've got a quadratic function, ax squared plus bx plus c. The fundamental inequality that we need to solve is where is it positive and where is it negative. If you can do this problem correctly, you can do any quadratic inequality correctly. Okay? So to solve it, you need to find where it's above and below the axis, and we'll do little manipulations whether the inequality is less than or bigger than 0, or maybe bigger than or equal to 0. Do you want to include the possibility of equaling 0 or not? We'll work through various iterations of this. So let's just do an example. X squared minus 2x minus 15 is less than or equal to 0. Graph the solution set. So we could start by graphing the function. Okay, it has a y-intercept of negative 15. To find the x-intercepts, okay, we can factor this. We could throw the quadratic equation at it, but this is one that's fairly easy to factor just by looking at it. Remember, it's called various different things. I've never referred to it by a handy mnemonic name or anything. We're just looking for numbers whose product is negative 15 and whose sum is negative 2, and what works is negative 5 and positive 3. Okay. How can one number times another be equal to 0? The only way, if I multiply x minus 5 and I multiply that by x plus 3 and I get out 0, if the product of two numbers is 0, either the first one was 0 or the second one was 0. And that tells me either x is 5 or x is minus 3. So here are our intercepts. If you applied the quadratic formula, up here you'd say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you would simplify this down, okay? Negative negative 2 is just 2. Okay, plus or minus, negative 2 squared is 4, and then I have negative 4 times 1 times negative 15, so that's positive 60, so I have the square root of 64, all over 2a, that's 2. The square root of 64 is 8, so I have 2 plus or minus 8 over 2. If I do 2 plus 8, I get 10. 10 over 2 is 5. 2 minus 8 is negative 6. Negative 6 over 2 is negative 3. You'll get the same answer. Okay. So if you are not very good at doing this factoring, you can do the quadratic formula as long as you are comfortable working through that. So we found two x-intercepts. Okay. So we have a y-intercept and two x-intercepts. So to find the vertex, we can apply this negative b over 2a. X is 1. Okay, and if I plug that in, we'll get out y is negative 16. So 1 comma negative 16 is the vertex. So now the question was, where was f of x less than 0? That was the fundamental question at the beginning. And we found an intercept at x equals minus 3, and we found an intercept at x equals 5. And because it is concave up, it has a minimum in between. Okay, and so the minimum will therefore be below the intercepts. So from x going between negative 3 and 5, we are below the axis. Okay, we don't want to include the intercepts because the original inequality up here didn't say less than or equal to 0, just said less than. Okay, so we can express that using either a set or an interval notation. Okay. I like how on the previous slide they tell us, oh, sorry, I just misremembered. I take this back. This was originally given as less than or equal to 0. So we do include the x-intercepts, my mistake. Okay. So we're going to include the intercepts. X is bigger than or equal to negative 3 and less than or equal to 5. In an interval notation, we would include them. Okay. And you can graph that on the number line if you want. Okay, example 2. Solve the inequality x squared less than x plus 6 and graph the solution set. Hint, all you have to know how to do is graph a quadratic compared to 0. That's my hint. I'll pause here. Okay. Option 1, rearrange the inequality so that 0 is on the right-hand side. So I'm going to subtract x plus 6 from both sides. This is really the same as the original problem. So we're going to graph this. So we're going to find the intercept. We're going to find x-intercepts. So we can either apply the quadratic formula or we can factor. This one, again, factors pretty nice. It's x minus 3 times x plus 2, which means x is either 3 or negative 2. So here are our two intercepts. So now I'm going to ask, does this have a minimum or a maximum? If it has a minimum, is the minimum positive or negative? And if it has a maximum, is it positive or negative? Well, we have two x-intercepts, and we are concave up. So it has to have a minimum, which is negative. Okay, we found intercepts. That's where the value of the function is 0. So in between, it's going to have a minimum, which has got to be below 0. Okay, so we have y-intercepts. We have two x-intercepts. Where's the vertex? Okay, x is 1/2, and y is negative 6.25. And there's a graph function. Where is the graph negative? Between the intercepts of negative 2 and 3. And this inequality was strict, so we're not going to include the intercepts themselves. Okay. The second way to do this, and I really caution that this is not preferred to me. Okay. I really think what you should do is just compare it to 0 and use the same techniques as before. You've got x squared and you've got x plus 6, and if you graph those individually, you find where they intersect, but notice we're doing the same work. We find the intersections of the two graphs. X can be 3 or negative 2 with the y value of 4 and 9. So here are the two intersections. Where is f of x, the parabola, less than, below, g of x, a line? Where is the parabola below the line? In between x equals negative 2 and x equals 3. Okay. So I'm actually going to go back a bit to show another mistake that's made by many students. So let's go back to the first way we did this one. Okay. So we factor like this, okay? So what a lot of students would do, let me give myself some blank space so I can show you exactly what goes wrong. So I'm just cautioning you, this is a common error. I always don't know whether I should tell you about common errors or not. I think it's helpful to be warned to not do this, but if you're not paying attention, you might just put this in your notes and think it's how you're supposed to do the problem. A lot of students will just mindlessly copy this down. Okay, don't do this. So they say, okay, I want x squared minus x minus 6 to be negative. This is the problem. Let's factor this. It's x minus 3 times x plus 2. Yay, we factored correctly. This is all fine. Okay, here's the error. So I want x minus 3 to be negative or x plus 2 to be negative, meaning I want x to be less than 3 or I want x to be less than minus 2. So I want everything up to 3, and I also want everything up to minus 2. Here's the error. Okay, one number times another is negative. If I'm multiplying two numbers together and the result is negative, they can't both be negative. What you really need is one of these to be negative and one of them to be positive. And you can logic your way through whether this is an or an and or an exclusive or and all that, but honestly, it's just way too easy to make a mistake when you do this. Do not factor an inequality and think that immediately gives you something about the individual factors. Don't do that, okay? We have a parabola. The correct way to do this, and I'll just go through the steps again to reinforce the correct way. Find the intercepts. The intercepts are at 3 and negative 2. I have an opening or a concave up parabola, and I have intercepts. So if I'm concave up and I have two intercepts, then I am negative in between them and I am positive away from them. That's the correct way to do this. Do not factor an inequality and then go to inequalities about the factors. That's an error students make. Don't do it. Okay, I'm going to go and finish off this example, and we'll go on to the next example. Okay. So actually, now that I say that, I'm just going to make example 3 a new video. Okay, so come on back for the rest of this section.